Hello everybody, and welcome to the second session of Handmade Runes, where we code a completely from scratch ray tracer graphics application. We'll be painting everything by hand. So, in this session, what we're going to do is we're going to want to have our own frame buffer, and we're going to just put pixel by pixel in there. And we want to show that frame buffer in our window. So where we last left off, we just had this empty window that kind of doesn't draw itself well. And today we want to basically put pixels in here and make the resizing work. So without further ado, this is the main enabler for us to do that. It's called set di bits to device. Function sets a pixel in the specified rectangle on the device that is associated with the destination device context using color data from a div, JPEG, or PNG image. Let's just start unpacking what that means. Well, we got pixels, and we got a rectangle, and we got a device, and we got a device context. And then we got this div thing, which is device independent bitmap. We technically won't even need to use a bitmap because we're going to be able, it's called set di bits. So bits, you see this pointer here, it's just a void pointer. So it can accept anything, and as long as it's some array that's what's called d-word aligned, so it's basically just an array of 32-bit integers that contains the color of the pixels. Okay, so that's what div means. We won't be using an image, a device independent bitmap, but we're just going to set the bits themselves. Okay, so what's a device context? So the device context is something that you get an opaque handle for, and by asking for it for a particular window, and it's just a way of Windows tracking down all the drawing operations that you can do. You can do a lot of things on a device context with the GDI API. So you can draw all kinds of shapes and stuff. We won't be using any of that. The only thing from GDI we're going to use is this guy right here, this function. That's it. But as you can see, we do have to fulfill all this stuff here. So we got like where we start, where we end. What the starting coordinate in the window that we want to paint to, the width and height, and then this is like the if we want to do some offset from the source that we want to take from. Start scan, we'll talk about this one as we get there. C lines, we're only gonna have one line, I think. Anyway, we'll get to that. And then we have color use. It's just some, let's just see here. Starting scan line of the image, it's going to be 0. We're going to start from the beginning. Pointer to the color data stores an array of bytes. See? For more information, see blah blah blah. Okay. We'll need this bitmap info. It's going to be a struct. It's just a struct that details the information of a bitmap. We don't actually need to have a bitmap, but we do need to have this thing that describes a bitmap. Okay, and then there's this last thing is we're going to use this guy. Device independent bitmap RGB colors. This is some older 16-bit thing we don't care about. Yeah, and you can see the align, blah blah blah. yeah, so let's start implementing all the binding all the and implementing all the things that we're gonna need to make this call happen. Let's start with the Bitmap Info. So Bitmap Info. Okay, so it's a struct. Has a Bitmap Info header. That's another struct, and that's where all the information is. And then it has this thing called RGB quads, which is gonna have an array of RGB quad elements of an array that makes up the color table. We're not gonna even use the color table, so we're just gonna have like one member of this array, which is going to be like a single RGB quad. Let's see what an RGB quad is. It's just a simple struct of bytes for RGB blue, RGB green, RGB red, and something called reserved. So technically this is the, like, we're gonna have like it's gonna expect us to give something that's gonna be an array of these things. We won't actually do this exactly like that, but you'll see. Anyway, so let's start binding with start the bindings and define definitions for the Win32 stuff that we had before. So okay, so one thing before we even start, I said just a correction of the prior video. I said that yeah, you need this thing, and I don't really know if we ever get there. That's actually not true. So what happens is we have this message that's coming here, and it's going to we're going to be handling the destroy thing, and then we're going to post a quit message with the status code 0, and you want to quit. But we won't actually get to here when we're handling this guy. So anything we are handling is not gonna go over here, right? It's in this case, and in Odin it's an automatic break. When we hit the end of the case section, it's gonna break, and then it's gonna go here, and it's returning 0. And we're returning 0 from this WinProc when we want to signal to Windows that we have handled this message type. Okay, back to where we were talking about. So we need to have this quad thing, and let's see. Right, it's gonna be a bunch of bytes, and technically in Odin you can just do this, right? Because they're all the same type. And we said we don't care about the tag thing. It is going to be a struct, and that's the name of the struct. That's one thing down. Let's go back here. So that's an RGB quad. Now we're gonna have this Bitmap Info header, and that's the big kahuna guy that's gonna actually contain all the information about our quote-unquote bitmap. So let's grab this guy. And here. D word long word D word long. We should probably have all of this defined already. And again, I'm gonna cheat here and do this, right? So we're just gonna end up like this. Okay, so we have D word. Cool. Go back to struct. We have longs, yeah, and oops. Sorry. And we have the word long and that's it, right? Yeah, okay. So we have the two types of the member of Bitmap Info. So this is going to be Bitmap Info, and oh, I don't think we have bytes. Okay. So what is a byte actually? We can go to our thing here that we were using. Say right? What's a byte? A byte is an unsigned charge, so it's going to be like a U8. So actually in Odin, yeah, so in Odin we do have like a byte type, in fact, so we can just use that. It should work, right? Alright, so now we got our, this guy and this guy, and all we just need now is the actual bitmap info. It just contains these. And as you can see, we're going to have just an array of one of this guy. We're not going to really use it. We're really actually concerned with all of this thing here. Let's see what they mean. Right, so number of bytes required by the struct. It's just the size of that struct, right? The width of I think because that array, right, can be of any length for the BMI colors, the RGB quad array, so it needs a size. Anyway, width is the thing that we need. Height, obviously. If b height is negative, including a top down, okay, so you know how in graphics there's these two conventions of like, are we drawing top to bottom or are we drawing bottom up in terms of how the values of y go? Are there like, is 0 of y, is it the top left or the bottom left? So the way we communicate to Windows which one we want is that if we give it a negative height value, indicating a top down, and we are going to do that. We want it to be from the top to the bottom. So our 0, 0 coordinate of the bitmap or the thing that we're going to draw is going to be at the top left. Compression, we don't need any compression, we don't care. Planes is not something that we're going to use. It says it has to be set to 1. Okay, I guess it's some historical bullshit. Bit count, we're going to use 32, I guess, right? Yeah, bitmap is a maximum. Wait, 2 to the 32 colors. Yeah, for like RGB and A, but it doesn't actually have A. It's like reserved or whatever. Look, it doesn't use it. We can technically do this, but we'll just use U32. 3 by triplets. Yeah, we'll just use 32. Okay, so that's the bit count. Compression, we don't care. Uncompressed, so BI RGB we're gonna need, which I guess it's a constant. Yeah, doesn't actually say, but we can check if we want. Yeah, it's 0. So can define this in our constants. be an alias to 0. Cool. Let's go back here. Anything else we need? I think this is it. Size image. The size in bytes of the image. This may be set to 0 for RGB bitmaps, which is what we have. Okay. Oh, it's because, okay, if it's compressed, then we care about this. Otherwise, we probably don't. Pixel per meter. Don't think we care about that at all. Clear the number of colors indexed in the color table. Actually, we're not using a color table. Okay. Yeah, we don't care about it. The number of color index that are required to display the bitmap. If this value is 0, all colors are required. Yeah, okay, fine. So we think we have what we need. Let's see. Yeah. Alright. So we need we're basically going to need just one instance of this entire struct, and we can leave a lot of stuff to 0, so we're just gonna need to say no compression, and we need the bit count, which is gonna be 32. Planes, it said had to be 1, right? What was it? Planes had to be 1, and this size thing. Alright, let's do that. So, just gonna copy this. So we're gonna have a bitmap info. We go to window. So I'm gonna start using some globals. I know it's a bad practice, and I wouldn't recommend doing it for production use, but oops, I lost it. For stuff that we're doing with this for training purposes, we'll just use globals. So we'll call that bitmap info, right? And we'll just call it info, whatever. And we can see that it has 2 members, and this is the bitmap info header. Right, so it's gonna be of this thing, first member. We can bitmap header. Oh, sorry. Right, and we need the size is gonna be size of whatever our bitmap info header. Width, we're gonna fill this somewhere else, you'll see. So we don't need these guys and this guy. Alright, compression we said we do need. Oh, sorry, it has to be equals. Compression we said compression, which was this guy. Sorry, keep jumping to the wrong place. Bit count is gonna be set 32. Planes we said we need to set it to 1. And yeah, width and height we're gonna fill up somewhere else, which you'll see. Yeah, okay. So this is that, and the other one, I guess we can just leave the default, which is gonna be just an empty array, I guess. We're not really using it. This RGB quad EMI colors, whatever that means. And we do have this defined, right? Okay. Alright. Let's continue on to back to our hero here, set DI bits to device. Okay, so we got ourselves the bitmap info, that's taken care of. What else do we not have yet? Let's see. HDC. What the hell is HDC? HDC, a handle to device context. Okay, how do we get, what's an HDC? Whatever. HDC, declare handle. It's just another one of these guys. Alright, let's do this. Types, and we have another handle. Alright, cool. But how do we get one? Because this is something that Windows needs to give us. Get DC. Okay. And we need to provide the window handle, which we already have. Okay. And where is this from? User 32. So we need to define a binding for this guy quickly. Let's do that. Bindings and user. Just put it all the way at the end here. Right, HDC is the thing that's gonna be returned, and it takes a window handle. It's a proc. Right. Let's go to our window, and we're going to use this device context in here also inside the WinProc when we're setting when we're painting, basically. So we're going to need to set it here and then use it here. There is a way we can just call this get DC in here every time. But if you remember from the first session, we talked about something called own DC that we defined here. That means that we're allowed to just have one of those and just reuse it and never destroy it, and never release it, just capture it once. And because we're only going to have one thing in the entire application that's going to be drawing, so we can acquire this DC only once. So we just need to define HDC, I guess, this, call it Windows DC, DC. Okay. And we're gonna get it here. Now this show window, I think it's gonna actually end up dispatching dispatching basically end up having this thing be called at least once to get the size and stuff. So we wanted to do this before, and you say win DC is gonna be equals to just calling this guy, and we do need to provide our window. Right, DC. If I can spell. Let's go back here, back to where we were. What else do we need? So, do we need the window handle? Doesn't look like it. Anyway, so we need to bind this thing now. So let's see where it is. GDI32. We don't have a GDI32 binding yet, but we can create one. So let's do that. Let's go to our bindings. And I'm gonna do the same thing we did here, and then we'll just change it to GDI instead of kernel. GDI, right? GDI. Yeah, okay. Anyway, so it's gonna be like this. And I'm gonna cheat again. Gonna go here, and we end up with this. Yeah, it's a bunch of ints. And this thing that we saw here was the void pointer, so we're using a raw pointer. And this thing is going to expect a pointer to our Bitmap Info struct. And this is the HDC, the handle to the device context that we've just instantiated and got from the window. Right? We have this already. We are good to go. So let's go to this. Right, GDI. Yeah, I don't think the has to be a capital G, maybe. I don't care. Whatever. Let's do it. Don't think I need it. Anyway, so we go to our window. So let's just start talking about how we're going to be painting stuff. So somewhere in here, in some case, which is going to be WM Paint, which we haven't defined yet, we'll need to define it. We're going to be invoking this procedure, right? So in here is going to be our WinDC, right? Where are we going to start drawing from? Just 0, 0, right? Width and height. Well, that's going to be our info, right? Our info.bmi header dot width. What was it called? Oh, we don't have it here because I removed it. bi width and bi height. Fine. So it's gonna be this. Sorry. Let's do it like that. Width and height. Alright. So that sells these guys. Source. Let's see. Again, we're starting from the beginning. 0, 0. Start scan. 0 again. See lines. I think it means how many lines of pixels you're gonna expect it to have. See the number of div scan lines, yeah. Okay, so it's basically our width, right? Unless we're doing something like if we're drawing something that's not the whole thing or whatever, so this could be different than width, but in our case it's not, so it's just gonna be the width. Right? Okay. And bits, now we're gonna have to pass some pointer to a bunch of bits. So we're gonna have to have some, that's our frame buffer. So we're gonna have some pixels, right? It's gonna be a pointer to an array of U32, just initially. And okay, let's think. How many pixels are we gonna have total? So let's say that we want to be able to draw up to 4K, because like that's kind of the maximum of the screen that people tend to have now. It should be more than enough for this test application. So we're gonna have like for max width, it's gonna be 3840, and our max height is gonna be 2160. Right, that's 4K if I remember correctly. Let's just do like max size. It's gonna be obviously this times that. These are all like compile time known constants, so we can just do this. Right, we have pixels. So the pixel is a pointer to an array of 4K of U32s, each of which is going to be presenting a pixel color value. Right? Where are we? Right here. Right? It's going to be our pixels right here. And now this is going to be the pointer to our Bitmap Info, which we already have right here. So we're gonna need the address of this guy. And the colors used, I think we talked about this one already, right? It's gonna be our constants, this guy, which is just 0, but well, we'll do this the right way, whatever. There we go. Alright. Okay. Or maybe not. Let me just double check. No, we used this Why did we use this? Oh, for the we use this in the compression right here. Yeah, I'm conflating it with something else. Let's see. I think we missed something. Oh, yeah, right. We need this guy. Okay, so we need another constant. Let's see what that constant is. Zero. Okay. Fine. We'll do it the correct way. We'll go to constants. We'll have another one of these that's also 0. Alright? Okay. Now we're good. It would have worked, but this is a more appropriate way. Now, we need to set our width and height. Oh, before that, what's WM Paint? Right? I don't think we have one. We have WM Destroy, but we don't have, and I mistyped it, obviously. So, we need to find out what is the hex value of WM Paint. That's the paint message. Any day now. It's this guy. Alright. Now, that's for the thing. So we said how are we gonna get what our size is? So we already set an initial size is 500 by 400, right? But we want to be able to handle the resize event, and then just, you know, anytime just tell it what the size is, right? Actually, just in case, let's just do this. It's not strictly necessary, but let's do it anyway. And we'll do like initial width, which we're gonna define. No, that's good. And we'll do initial height. 600. Let's bring all these guys up to here, right? And we're gonna have this thing. Initial height. Now let's use those at the bottom here. Initial width, initial height. Okay. So now our window size. Okay, we need to talk about something. It's not gonna be exactly the same. So the thing to know here is that yeah, I think this is why I didn't like doing it like this. So there's like the size of the window itself, which is what we're giving here, right? And then there's the size of the rectangle inside the window where we are actually painting, which is not exactly the same, because you have the, you know, scroll bar, or like the title bar, and you could have like menus maybe, and you have like the edges of the window, and all of those are actually included inside the window. And we want to be drawing into just the the rectangle that we're supposed to be drawing to. So we need to get some rectangle to draw into. I think it talks about this here. Let's see. Well, maybe not. Yeah, it's not mentioned here. Anywho, it's one of those things that you kind of have to know. But let's see. Let's see what we got here. See, as W paint. By the way, this is what you'll see often, and we're not going to be using that. We'll talk about that. Basically, you do like a begin paint and then end paint, and then it knows that that you've started drawing, etc. There's an actual cheaper way to do it. To use calls that these call into indirectly. Do we have it here? Don't think we do. Anywho, so I'm just gonna explain it. So we need to ask window what is the rectangular that is that we should be painting into, right? So it's this function. If you would look for it, retrieve the coordinates of a Windows client area. Client coordinates specify the upper left, lower right corners of the client area, because client coordinates are retrieved to the upper left corner, blah blah blah, of the client area. Okay, so we need this guy, and handle to the window we already have, and this guy we don't have. It's a, again, long pointer to a rect, and we'll see what a rect is. It's right here. But this thing is user32. Let's bind it. Binding win32. It's returning a bool. It's a proc. Right. Done this a million times already. It's small enough, so I'll just do it by hand. Okay. So what's this LP rect? It's gonna be like a pointer to a rect. Whatever. LP rect. It's a pointer to a rect, and this is a rect. Okay. So let's do this rect thing. It's just a bunch of longs, which we already have. So don't care about this. It's gonna be a rect, right? And all of these are longs. Done. And we already have a long, right? Yeah. Okay. And then in types we can say that LP rect LP rect is gonna be a pointer to rect. Alright. Just so we can satisfy the binding here, this guy. Okay, so we got get client rect. We need to provide it a window, and we need to provide it a rect. We need to instantiate a rect. Yeah, let's do it here, I think. And rect, it's gonna be a rect. Yeah, and okay, so somewhere in here we're gonna need to call the client. To get our client drawing area, and it says we needed the window, which is the handle window, and our win rect. Gonna need the address of it because it expects a pointer. Now, when are we gonna call this? So it's gonna be a WM size. That's the event that, the message that Windows sends whenever the window is resized, and it has this value. Alright, and yeah, so anyway, we don't care about those things. We'll just call this this function, and it'll tell us this procedure, and it'll tell us, it'll fill up our structure with whatever the new size is. Last thing we need to do is we need constants. So WM size is gonna be that thing that I just copied. Alright, this guy. Alright. So whenever Windows calls this dispatches this message about sizing, we're gonna grab what our new client rect area, and we need to populate our bitmap header info with the sizes based on whatever was populated into winrect by this call. So now this rect thing has like a top, bottom, left, right thing, right? As we can see here, left, top, right, bottom. So out of these we need to extract a width and a height. So the width is going to be obviously the right minus the left. Alright, it's going to be our win rect thing. Right? Yeah. And for the height, so let's think about it. So at the default, we're gonna get like a top and a bottom, right? Yeah. So we need the top minus the bottom. Now, we can actually just print stuff and see what we get, because you remember we need to have the height negative if we want to draw top to bottom, right? So based on whatever we get is top and whatever we get is bottom, which one of these is going to be actual higher value, then this height is going to be positive or negative. Let's see if we can do some print debugging and start seeing even if it works or not. So we can start printf debugging and see what we get here. So import core fmt. Alright, let's just do fmt print line. Let's see, can we just print a full unstruct? I think we can. So let's print direct itself. After that we can print yeah, the info header. And of course we have errors. Let's see, syntax error expected. Okay, window line 22. We are in window line 22. Oh, okay. And line 41. Line 41. Oops. It's this guy. Okay. Whoa. Okay, max width, max height, invalid declaration. Why? Okay, let's see. Size of, obviously, that should be this. We'll get back to this in a bit. Okay. Window. Oh. So I think we need our window to be also global because, yeah, we're gonna need it here. Okay. So there's a window. There's a window. So we're just gonna assign it. We're actually gonna define it right here. It's gonna be a handle to window, if I remember correctly. Right? Yeah. Alright. And this is still bad. Let's see. Max width. Oh. Yeah. Max height times width is size. Good. Okay. Oh. Okay. Well. Yeah. Okay. Well, we can start talking about this now. So there's a problem that we haven't addressed in the last lesson that we're gonna have to address here anyway, which is that we can actually call regular loading procedures with the regular loading default calling convention within the context of a procedure that has the std calling convention. The reason is that the default loading calling convention expects an implicit context argument as like the last argument, I think, and there's not going to be any context here because this is a different calling convention. So within here, there's not going to be any context for it to be able to make this call or any other call that we want to do, and we will want to do other calls to Odin regular procedures. So we need to define a context in here. So we need to be able to say context equals something for this to work. So context, let's say we're gonna need to define some default context, and we'll define that as a global, and we're gonna populate it from somewhere else that is not a procedure like that. So we're gonna do default context, and this default context is gonna be of type runtime.context, and we need to import core runtime. And we need to populate this from something that is not like this, which we do have right here. So in the run application, we're going to populate this with runtime default context. Yeah. Okay. So once it's gonna, because in here it's a regular Odin procedure with the default Odin calling convention, which has a context. So we can just do runtime default context, populate it once in a global, and then whenever this gets invoked, we're populating the current context of this thing to be whatever we said here, and now we can make calls to regular Odin procedures with the Odin calling convention. Okay, that was kind of a long-winded explanation, but we needed it. And of course I need to fix this. Cannot assign value of type. Okay, fine. So we need this to be actually, is that true? I32 to U32. So this is going to be a U32 and this is an I32? Is that right? Let's see. Where is it? So this is a long, and the long is an I32. Okay. And second, our header struct is also a long. So what's the problem? This should totally work. Line 58. Oh, it's not even in here. Oh, it's in here. Oh, okay. Okay, so set di bits expects. Yeah. Right? Expects a D word for width and height. D words is a U32. Okay. Fine then. So we need to cast it. It's fine. It's not gonna be yeah. Well, I guess we'll find out. Okay, so let's do this. Once it runs, we'll see if we're needing to flip it. Good, assign of type. Oh, wait, what? Oh, okay. Oh, wait. Oh, we have this guy here. I thought, okay. Sorry. We need these guys to always be unsigned. Alright, we have our window. And look, even without resizing anything, it already got into our this handle. And we're seeing that our rect has bottom with a high number and top with 0. So top is 0, bottom is going to be this guy, so this is going to be negative, right? But yeah, okay, anyway, so also you can see that when we change, see, we're getting all these messages, and I'm gonna change it and we see more and more messages. Okay, now so what's going on here is that this is actually like word, right? The same, but just so these guys have to be unsigned, right? But this guy is signed, so it's gonna have it's gonna be negative, right? And we can see the height is negative, which is what we want, because then we'll be able to draw from top to bottom. Anyway, so we don't need this anymore. We don't need the print thumbed thing. We will still need all this context BS, because we will be calling other things from here. Okay, let's start talking about our pixels here. We haven't actually even filled this thing with anything. It's just a pointer to nothing at this point. So we need to allocate the pixels somewhere, and we need to basically store the width and height in somewhere that our application can access. And as you'll see, it's just a U32, right? So there's nothing Win32 specific about this. It's just a 32-bit unsigned integer. That's where it is. And we're gonna need like a width and a height, and it's never gonna be more than 65,000, so it could be an unsigned 16. We can wrap all this thing with a struct that we can call frame buffer, right? And we can move this thing to our application, actually, so it can be here. and we're gonna have one global instance of it because we're not painting to multiple windows. And actually, yeah, we can move these as well. Because we need this max size here. Alright. Okay. So let's say, yeah, we'll do this. Okay. So we're going to instantiate this struct, and we need pixels to be new. And let's see. Some pointer, and we're gonna cast it to U32. Sorry, pointer to U32. Right. Actually, we need to heap allocator. So we need yeah, okay. We need to import core.m. Put it up here. We actually need to cast it to an array by the pointer to basically this type, right? Yeah. So we're gonna need to cast whatever is being returned from mem.alloc. Okay, we could do like an arena allocator. We can actually do our own arena allocator. I actually did that in my project. I think it's just simpler for training purposes to just do the simplest thing. So we need max size times max size of U32, right? Which is 4, but yeah, whatever. Yeah, we can do like, what's the size of a pixel? Just say 4 or whatever. Okay, so this is how much memory we need, and we're gonna get a pointer to it, and we're casting it to a pointer to an array with this size of U32s. Okay, so now we have the pixels. I'm not initializing width and height because we are gonna do it as we saw in here. Anytime this gets resized, which will get called at the first thing even before we resize, as we saw, triggered by this guy, because the window gets shown, it calls this once. So we're gonna get the WinRect, we're gonna compute the width and height, and we're gonna do, now it's, yeah, we need application dot frame buffer dot width is gonna be this guy, but it's actually gonna be no, yeah, this guy's gonna be this, but we do need to cast it to U16 because it's currently an I32, and we need to do the same for the height, but we want the width and height in our frame buffer to just be a positive thing, and we saw that our height is negative because we're doing 0 minus positive number. So we're just gonna negate it, and then it's positive, and then we downcast it to use 16 because it's never gonna be larger than this. And now we have our frame buffer size appropriately. And in fact, we can start talking about making our application plug into the platform layer, as we discussed in the introduction video to the application design. So we can say resize, going to be a proc, right? It's going to have a width and height, and I can, for convenience, say this is an I32, right? Or like, yeah, an I32, and we can move this call here, and then it's just a frame buffer. And again, I'm using globals for convenience for the purpose of training. I'm not recommending to have this as a global here. And yeah, so width and height. Now we can just call this from here, right? Resize application.resize, right? And we're gonna need to pass these two. Now we can actually do like this using, right, just for less typing, width and height. Now we can actually, if we really wanted to do it using WinRect, and we just have these guys. Nice and clean. Okay, so now every time our application, our window gets resized, our frame buffer will be resized here, right? There is new with the new height. Okay, and then we can do, if we want, using frame buffer. Alright, this is how we update. We may actually end up doing more things in the resize if we need to later, but this is now, we've exposed a resize procedure, like callback, from our application layer to the platform layer, and all it cares about is to receive some width and height. Actually, let's do this. Because in here we want to flip the height, right? And we need to convert it here, use 16. Okay, so now our application is resizable. Now pixels. So in here we're gonna need to do application.frame buffer.pixels, right? and the word is U32. Okay, whatever. Okay. So let's talk about what we're doing with the painting. So what's going on is Windows issues this double paint wherever it needs to paint something, and it only needs to paint something where the some region within the window is invalid. So it keeps track of regions within the window that are valid or not valid, and wherever some region within the window gets invalidated, then it calls this mPaint, and we need to draw it and then revalidate the region of the window. Okay, that's kind of what like begin paint and end paint. But begin paint and end paint needs like a brush, and then we need to define a brush and blah blah blah, and maybe we need like a bitmap or a DC. We don't need any of that crap. We're just sending pixels, right? Raw pixel array. But we do need to tell window, hey, we've revalidated the window, like the region within the window. And we do this with this call to validate the region, right? It takes a window handle, and it takes a region, but the region can be null, and then it's like the entire client area. This is exactly what we want, because we're going to be filling the entire client area every time, right? So let's copy this, and this is from user 32. So let's go to our bindings with 32, and we already have a bowl. Right, now we have a window handle. We don't have a region handle, so we'll need to add that. And what's a age region? It's probably just another BS. Yeah, okay. So let's do that. In our types, we're gonna have another one of these, like so. Okay, so a handle for a region, and it's gonna be void because we wanna invalidate the entire client area, because we're drawing the entire window. So, oops, validate region, passing our window. That's the window handle, and nil because we wanted to for everything. Okay, that's all we need here. And but once we validated it, we need to unvalidate it every time we kind of update in our main loop. So right in here. So what's going to happen? So we're showing the window. It'll call the resize thing once, the size, and then we're going to resize our frame buffer. And then we need to have it call the paint. Okay. Currently, let's bring back the thing just for import for font. Let's see when we're getting paint messages. Font print line painting. Okay. What did we get wrong? Syntax error in bindings. What did I do wrong? Because I forgot to say proc. 81. Yeah, that's this. That's fine. Application. Okay. 11. Oh. It's a structure definition. Application 15. Oh, I don't need this. Path does not exist, core mem. Did I do this wrong? Okay. Alright. So we're painting, as you can see, but only once. So that's not great. But when I resize, we're painting. So that's good. Whoa. What we actually want to paint continuously, right? Not just when we resize. Okay, so we'll do this again. See, we've only painted once. We want to, oh, come on, Windows. Stop it. It's because I'm wiggling this window. Because Windows has this feature when you do this. See? It's a gesture. It means something. It means I want to close everything except this. Oh my god. Yeah, Windows. Anyway. So we need to tell Windows that we want to paint every time we loop through this loop thing. So in here, every time we empty our messages and we go to another round through our main loop, we want to say, hey, make it such that you call you emit a paint message, right? So you get repainted. And the way we do that is we do the opposite of this. We invalidate our entire window, right? So invalidate region. I suppose. Supposing that this thing exists. Okay, let's see. Is there a thing like that? Invalidate region. What do you know? Oh, it has a bool. Okay. Erase. Specifies whether the background within the update region should be erased when the update region is processed. The parameter is true, the background is erased. The begin paint functions go, blah blah, we're not using begin. We can do false because we're going to be drawing on top of everything anyway. Anyway, so we just need to add this thing into our bindings. I think this is going to be the last thing that we do. Right, block. It's going to return a bool for some reason. Whatever. Erase region. It's going to be nil. And our window. Right? So we're invalidating the window all the time. Boom. Now we're passing false. Okay. Now I'm launching. And now we're painting as fast as we can. Okay? That's a lot of painting. Okay. So now our painting loop works. We can get rid of this guy. In the future, we'll make it so that it doesn't paint more than 60 times a second because it's kind of wasteful, but we'll get to that later. But we're painting, so let's paint some stuff, right? We don't need this guy anymore. So where are we gonna paint? It's gonna be inside our application. So let's do like application.update. Let's make some procedure here that we'll call update, and here we're gonna fill this our frame buffer with some pixel colors. Okay, so let's just loop for height in 0 to up to frame buffer dot height. Right, and the same for width inside here. Width, and we can do this using frame buffer. Okay. And let's do like a pixel. We'll say it's a pointer to U32, and we'll also have like an index, a pixel index, and it's going to be a U32. It's going to start with 0, and every time inside our nested loop we're going to increment our index of the pixel, right? Index plus equals 1, and in here we're gonna do like pixels. That's the frame buffer's pixels. An index, and the address of this is gonna be pixel. Okay. So just looping with width and height, starting with the height, and then inside each row of our height we're gonna looping through all the pixels from left to right, and each time we're incrementing the index. So this array is actually a one-dimensional array, as you can see, right? And it just contains like the maximum number of pixels that can go in a 4K dimension frame buffer, which we'll never get to, but it's like a safe thing to allocate, and we'll just reuse it. And whenever our frame buffer gets resized, we'll just loop here up to where we're getting, right, up to the current width and height, the current pixel that until the last pixel given this width and height. So we're reusing the frame buffer. We're not resizing, and we're not reallocating anything when we resize. Okay, it's just drawing a fewer things, and that's the same thing that in here when we're providing this info thing, because every time we resize, including in the first time the application runs, we're updating our width and height here, right, in our info BMI header. So in this case, and we're using the same array, right, the same array in our frame buffer every time. We're just saying, hey, these are the dimensions, right? So it's gonna read from our pixels array only up to where it needs to. Okay, and we're gonna, on the application side, we're gonna write using the same heuristic, right? The same methodology, right? We're just gonna write up to the last pixel of the width, number of pixels of the width at the last row of pixels in the height. Okay, but otherwise we're just reusing the frame buffer even as our window gets resized. So let's think what pixels values we actually want to put here. So our pixel is U32. So pixel colors can have different formats. It could be like, if we have our U32, it's like 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4, right? 32 bits. Let's say that it goes from right to left, so these are the lower bits, and those are higher bits, higher bits, higher bits. Now, we don't really care about this guy because it's not going to be used. We only care about the first three. Now, could be, let's say it's alpha, but it's not actually alpha in this case, but it could be like R, right? G, like green, red, green, and blue. Could be like this, or it could be green, blue, sorry, could be like blue, green, and red. Because it could be like R, G, B, A, right? From the low bits. But for some historical reason, people didn't like to, in the debugger, see it like this, even though this is the correct one, right? RGB, correct. I mean, the one that makes sense. They like to see it like R, then G, then B, right? So Windows actually uses this guy. So it's BGR if we do, I think. So let's find out actually. So we have pixels. We have a pixel, right? And we want to put, let's just put, fill the first 8 bits with 1. And the rest is going to be left at 0, and see what we get. Now in a window, I had a suspicion that we are doing something wrong here. So because this guy this guy can be negative, and we're just casting it without negating it. So let's just do, use our frame buffer. Application dot, actually let's just do using application, and then using frame buffer, right? This application update, and we'll just say now height and width. That's from our frame buffer now. Width, right? And pixels. That's nice and clean. Alright, let's see what we get. Look at this, we're getting a blue screen, but it's not altogether full. Whoa, something is wrong. Okay. So width and height. Oh, okay, so this was wrong all the way. It should be height because it should be like the number of scan lines. The number of scan lines is the height, not the width. There we go. So we're getting this blue-ish color, right? Let's push it 8 bits to the left. Now we're getting green. Let's push it 2 bytes to the left. Now we're getting red. Okay? So as I said, it's gonna be this guy, right? We got blue, then we got green, then we got red, and we don't care about the other one. Okay, so instead of doing all this crap, there's actually a better way to fill pixels. So what we're gonna do is we're gonna have a pixel struct, right? And it's gonna actually be a union between a value, which is gonna be U32, and a color, which is gonna be a color that we're gonna define. So color is gonna be a struct, okay, of, so we said the first is the blue, and then is the green, and then is the red. That's what we saw. And say A, whatever. And that's a U8. Okay? And we don't want, just to be sure, we don't want padding between those, so we say packed. And for this guy, we want it to actually be like a, it's not going to be like a union like this. We want it to actually be like a raw union, like in C. Right? Because we want both of these to overlap over the same thing. Don't need to have like a discriminating union or anything. So now we have two ways of putting pixels, right? You can use the value itself and you can use the color. So we can cast this. I don't think we actually need to, but let's just do it. We can cast this to U32 pointer, the pixel, because we're gonna be saying that it's gonna be an array of pixels now, not an array of U32s. Yeah. And then in here, we're gonna have our pixel here be a pointer to a pixel instead, right? And then, well, we can say dot value, and then we get the same behavior as we did before. Let's see. Oh no! Yeah, we need to cast it to pixel. So we're getting the same, oh come on, we're getting the same behavior, right, as we did before, just by using dot value. But instead of that, what we can do is just say dot color dot R is this, and then we don't need to move it by 16 because it's already placed in a 16-bit inward, right, 2 bytes in. Let's see what we get. See, we get the same thing. And now we can say we want it to be blue. And now it's blue, right? Or green. And now it's green. Cool. So now we can draw pixels. So what we could do, we can say, well, green is going to be, and we're going to cast it to a U8 because it has to be a U8. We can put it, the green to be the width, and we can say the blue is going to be the height, right? And obviously once those go beyond 255, then we're just going to wrap around, right? Let's see what we get. Look at that. We get a lovely picture like this. And resizing still works. So every 255 pixels is going to wrap around and start from 0 again for the green, and then the blue over here. Is that right? Yeah. Anyway, you get the idea. So we've made it. We have a window, and it's well behaved, and it's drawing pixels, any pixels we want, right? And it's resizing, and it could go up to 4K, right? That's it, guys and girls, ladies and gentlemen, for this session. We have reached our goal. So I will see you in the next session. Bye.